Okay, guys, we're going to start 11.5. I'm going to try and focus this. So 11.5, explore solids. A polyhedron is a solid that is bounded by polygons called faces that enclose a single region of space. An edge of a polyhedron is a line segment. So a face is one of the sides. The edge is where two faces meet. Is a line segment formed by the intersection of two faces. A vertex of a polyhedron is a point where three or more edges meet. The plural of polyhedron is polyhedra or polyhedrons. So vertex is right there. Make sure that you include that picture in your notes. Make sure you copy this key concepts. Type of solids. So this is a polyhedra or polyhedron. A prism, anything that has flat sides like this, or a pyramid, these are not polyhedra. You notice all of the sides are curved. So for the bottom, we're going to classify solids. Of the 5 solids above, the prism and the pyramid are polyhedra. To name a prism or a pyramid, use the shape of the base. A pentagonal prism, which is this, has the two bases of a prism are congruent polygons in parallel planes. A triangular pyramid, the base of a pyramid is a polygon. So now we're going to go to example 1. Example 1 gives us 3 shapes, and it wants us to tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So when we look at the first one, we have flat sides. That's how we know. And it's a prism. It's a rectangular prism. If we count the faces, starting from the top, so we have 1, 2, 3, 4, 5, 6 faces, which it tells us here. 8 vertices, so that's all the corners, 1, 2, 3, 4, 5, 6, 7, 8, and then 12 edges, starting from the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. For B, it is a polyhedron also, since it has flat sides, and it is considered a hexagonal pyramid. So for the faces, we have 1, 2, 3, 4, 5, 6 faces. Sorry, 7. 1, 2, 4, 5, 6, 7 is the bottom. So 7 faces. It has, what do we have to look for next? 7 vertices. 1, 2, 3, 4, 5, 6, 7 vertices, and then edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. And then the last one is a cone, which is not a polyhedron. Our next theorem is Euler's theorem. And what this theorem says is the number of faces, vertices, and edges of a polyhedron are related by this formula. F is for faces, V is for vertices, is equal to edges plus 2. So now we're going to do example 2. Make sure you put Euler's theorem into your notes. So we have this house, and it wants us to find the number of edges on the frame of the house using Euler's theorem. So I drew a picture of the house. So we want to find how many edges. So we're going to enter the faces and the vertices. So let's start with faces. So we have 1, 2, 3, 4, 5, 6, 7 faces. So everywhere there's a side. So 7 plus, now let's count the vertices. So everywhere there's 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's see. Yep, that's what they got too. Is equal to E plus 2. So we have 17 is equal to E plus 2. So minus 2, minus 2. There should be 15 edges if we count it. And that's it. That is all of, oh no, my bad. There are 2 more examples. I thought that was it. So let's go back. So this is the next section. So it says, a polyhedron is regular if all of its faces are congruent regular polygons. A polyhedron is convex if any 2 points on its surface can be connected by a segment that lies entirely inside or on the polyhedron. If this segment goes outside the polyhedron, then the polyhedron is non-convex or concave. So here it shows a picture of a convex polyhedron, concave. So just like how it sounds, it caves in. That's what makes it concave. So then there are 5 regular polyhedra called Platonic solids after the Greek philosopher Plato. The 5 Platonic solids are shown. So make sure you copy that into your notes. There are only 5 regular polyhedra because the sum of the measures of the angles that meet at a vertex of a convex polyhedron must be less than 360. This means that the only possible combinations of regular polygons at a vertex that will be from a polyhedron are 3, 4, or 5 triangles, 3 squares, and 3 pentagons. So for example 3, it wants us to find the number of faces, vertices, and edges of the regular octahedron, and they want us to check your answer using Euler's theorem. So here they give us a picture of the octahedron. So by counting on the diagram, it has 8 faces. So 1, 2, 3, 4, 5, 6, 7, 8. Vertices, starting from the top, 1, 2, 3, 4, 5, 6 vertices, and then 12 edges. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So when you plug everything in, the equation should balance. It should equal each other. Both sides should equal, which it does. So cross sections. So imagine a plane slicing through a solid. The intersection of the plane and the solid is called a cross section. For example, the diagram shows that an intersection of a plane and a triangular pyramid is a triangle. So if you have this pyramid like this, if you were to slice it, you're going to get whatever the base of that pyramid is. So if it's triangular, you're going to get a triangle as part of the cross section. Oops, right there. So for example 4, it wants us to describe the shape formed by the intersection of the plane and the cube. So if we have this cube right there and we slice it this way, looking at it from the top, you would get that same exact shape as the base since it's cutting it horizontally like that. So we would get a square. For this one, when you cut it, the same prism, if you cut it on a diagonal like this, it's not going to be exactly a square. It's going to be elongated. So you're going to get that rectangle shape. than if you cut like an angle off the way it's showing, you're going to be left with the trapezoid. So the end of 11.5, make sure that you go back and pause if you didn't take any notes on the formulas and the theorems, and start the homework and look for the next video on 11.6. Bye.